is, if we have a polynomial and it ends in this constant term d, we know that this m factor, the n part of the x, the bracket part, it must be a factor of d. Okay, and the converse is also possible. So if I have d, the only possibilities for these brackets is factors of d. So when I look at a polynomial like this and I think, what are the possible factors I can test in the remainder theorem? I just need to look at this constant term. Okay, so that's what I'm going to do. I'm just going to look at this constant term here and say, well, I don't need to worry about 7 as a possible factor. I don't need to worry about 5 as a possible factor. I know that my possible factors are just going to be plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, and plus minus 12. Okay, and I don't have to worry about any other ones. Now 12 has lots of factors actually, and so there's actually lots of possibilities. Most of the times we're not going to necessarily have this many possibilities, but even if we do, at least we know we're limited to what we can test. And in fact, we're probably just going to test these ones here. Now what happens if we have this a in front? Okay, well, with the a in front, we have to worry about possibilities of rational roots. Okay, so we can have factors that look like this, nx minus m, and it's always the back divided by the front is my root. Okay, so I'm going to write it this way. It's always back divided by the front. Where's that color? I don't know where that color is. Maybe just use brown here. Back divided by the front. Okay, where the front is at n value. That's really thick. Okay, back divided by, let's try thinner brown. Let's try that one. Okay, so the root is always going to be given as back divided by front. So when I have this polynomial here, I know that my whole number roots, or my integer roots, are going to be factors of 4. But I also know that there's possibilities of those roots being divisible by factors of 6. Now, in the end, we're probably never going to test fractional roots, but we should know the possibilities that they exist. Okay, so what we want to do is be able to, although we're not going to use all these roots, I want you to be able to show me what they are. Okay, so if we have this 4 here, the possible roots are going to be plus minus 1, plus minus 2, plus minus 4, based on that d value. Okay? We also have possibilities of rational roots when we divide by the factors of 6. So we can then have plus minus 1 divided by 2, because we have factors of 2 here. 2 divided by 2, well, we don't need to do 2 divided by 2 because that's redundant. Okay, although if I wrote 2 divided by 2, that's perfectly fine. Okay, but I'm just going to leave that one out because that is a redundant root. I can have 4 divided by 2 plus minus 4 divided by 2. Okay, again, that's a redundant root, so I'm not going to keep that in there. And then I just divide, the other divisors are 3 and 6. So I'm going to then say, well, I could have 1 plus minus 1 over 3 plus minus 2 over 3 plus minus 4 over 3. And then I can do the divisors of 6. So plus minus 1 over 6 plus minus 2 over 6. Well, the 2 over 6 is a redundant one because we have it right there. Okay, so I'm going to not put that one down. And plus minus 4 over 6. Again, 4 over 6 is redundant, so although if you leave it in, that's perfectly fine. I'm just going to leave it like that. So those are all my possible factors. Okay, so it's important to be able to identify the rational ones, but realistically, we will never use these ones for our remainder theorem test. Okay, we're most likely going to be able to find a factor using these.